Okay, class. Let's now learn the derivative of the transform. If you have one function, then you want to Laplace the function that combine with the polynomial and then one function of ft. So you will get the answer by taking the negative 1 power of n, and then you need to differentiate nth time for the fs you have, this one. Okay, the most important part for the derivative of the transform over here is you need to understand you can apply the theorem on the derivative of the transform when it's combined between polynomial and another function of ft. So from polynomial over here, you will have what is the value of n. So the value of n here, you need to substitute over here, and it's determine how many times you need to differentiate your function of fs that you got from this ft. Okay, let me give you one example. Okay, if you want to Laplace between the t power of 3 exponent negative 2t, so what is the answer? Previously, you have countered this type of problem by using the first shift theorem. Why? Because of the first shift theorem, it's the combination of the function between one of the exponent function and another ft. Now the derivative of the transform is the combinations of the polynomial and another ft. So it's actually complement each other. Okay, so now let me use the theorems of the derivative of the transform. So from here, you know that you can use the theorem of the derivative of the transform when you confirm that this is the combination of the polynomial and then another ft function. Okay, so now that polynomial over here, you will know that you have n is equal to 3. And then your ft is equal to exponent negative 2t. From ft over here, so you will get your fs. So what is your fs? Is 1 over s plus 2. So this is your fs. You can get from the table. Okay, so now the answer of the Laplace between the polynomial t power of 3 with the exponent negative 2t, you will get from the negative 1 over here, power with n, 3, and then you need to differentiate 3 times of, okay, you need to differentiate 3 times of the function of fs that you have over here. 1 plus s 1 over s plus 2. Okay, so if you have d over ds, okay, for 1 s plus 2, so the answer is what, class? The answer is, okay, so you just need to have d over ds. So I just put s plus 2 negative 1. So you will have here is negative 1 s plus 2 power of negative 2. And then you need to proceed with another d over ds. You just need to proceed with this one. Negative over here, s plus 2 negative 2 over here. So the answer is negative. So negative 2 over here, s plus 2 negative 3. Okay, so the answer is 2 s plus 2 negative 3. Okay, for the last one, what you need to do is you need to differentiate the answer that you have. 2 over here, s plus 2 negative 3 over here. So the answer is, so you will have negative 3 s plus 2 over here, negative 4. So the answer is negative 6 over s plus 2 power of 4. So now you combined your answer. Okay, your answer, which is, if you want to Laplace over here, okay, I just put over here again, Laplace between t squared and exponent negative 2t. Alright, so it's actually negative 1 power of 3, negative 1 power of 3, and then the answer for this one, negative 6 x plus 2 power of 2. So you will have this one is actually negative 1. So the answer is 6 s plus 2 power of 2. So this is the answer for this one. Okay, is it plus 2 over here? No, it's plus 4. It's power of 4 over here. Alright, so this is the answer that you need to find. However, for this one is actually you may use the first shift theorem. The first shift theorem is actually if you want to, like say, negative 2t over here and t squared over here. So it said that you will have this one. So you will have your a over here. So the answer of your that problem is fs minus with minus 2. Right. Okay. So you will have f s plus 2. So now you will have your ft. So your ft is t squared. And then what you will get is, okay, so you have t squared over here. The problem is, no, it's t cube. Right, I'm sorry. So this is the t cube over here. So we have a t cube over here, t cube over here. So your fs is equal to 3 factorial over s 4. So the answer from the first shift theorem for the combination of the exponent negative 2t with t power of 3 is this one with the s plus 2. So 3 factorial is equal to 6, and then you will have s plus 2 is equal to 4. By looking at this one, so it's the similar answer you will get with this one. The first one, you use the derivative of the transform. The second one, you use the first shift theorem. Alright, it's similar way. However, please be careful. Look at the question, which method or which theorem that you need to use.